Evaluate inverse sine functions without using a calculator. Finding the inverse of a trig function is like going backwards. For instance, we have sine of pi over 6 is equal to 1/2. Given the angle of pi over 6, what is the value? That's what we've been doing. The inverse sine of 1/2 is equal to pi over 6. Now we're given the value, what is the angle? So here we've got the value, here we've got the angle. So it's like going backwards. Let's recall from our lesson on graphing, when we graphed f of x is equal to sine x. It did not pass the horizontal line test. It was not 1-to-1. So what we had to do was we had to restrict the domain to be able to have our inverse as a function. So with y is equal to arcsine of x, or we can also call it, like what I've been doing, y is equal to inverse sine of x. We have to restrict our domain from a -1 to 1, and we have to restrict our range of our inverse function from a -pi over 2 to pi over 2. So when we look at our range, let me scoot this up just a little. When we look at our range, we can see if we had a unit circle, this would be pi over 2, and this is a -pi over 2. Our range is restricted to the right side of the circle. So our range is going to go from here to here. So it's going to be on the right side of the unit circle. Use this information to evaluate inverse sine functions. Now let's look at some exercises. If possible, find the exact value of the inverse sine function. Well, we have inverse sine of square root of 2 over 2. We know that it's going to fall between these two quadrants as far as our range. But before we do that, let's check and look to see about our domain. We know that our restricted domain of our inverse function is between a -1 and 1. Well, does that fall within that restriction? The square root of 2 over 2, if you put that in their calculator, that's about 0.7. So it does fall there. All right, so now let's look and make sure in our range where it would fall. The square root of 2 over 2 is 45 degrees, or it's pi over 4. So for it to be positive, it would fall about in here at pi over 4. So this would be pi over 4. Now let's look at arcsine. It's the same as inverse sine. I just want you to see that whenever I'm changing them, they are the same. All right, let's check, first of all, our restricted domain. Our restricted domain we know is a -1 to 1. Okay, that falls between there because that'd be a -0.5. And so we go over and now look and check our range to see, is it going to fall between here and here? All right, where is sine 1/2? Well, it's 1/2 at pi over 6 at 30 degrees. It is a -1/2 at a -pi over 6. So this is a -pi over 6. Now, let's look at the next one. I'm going to scoot this up. And we can see that inverse sine of the square root, the negative square root of 3 over 2, is where? Well, let's check, first of all, let's check our to see if it's within our restricted domain. Okay, but to -1 and 1. And I know that if I put that in the calculator, it's about a -0.86, and that falls there, so it's fine. Now let's check and see where it is within our range. So from here to here, I know that the square root of 3 over 2, sine is positive at a pi over 3. Well, I know it's negative at a -pi over 3. Now, let's scoot this up a little bit more. And let's look at inverse sine of 3. Inverse sine of 3. Well, the first thing we're going to do is we're going to check our restricted domain, -1, 1. Does 3 fall between a -1 and 1. No, this is not possible. This is not possible. Let's look at the next one. Inverse sine of pi over 2. Well, if we check our domain first, we know that pi over 2 is approximately 1.57. Does that fit within our restricted domain? So no, it's not possible. There's no solution. No solution.